Let's talk about how to determine the amount of solute we need to make a solution and how to make a stock solution, and then to dilute that stock solution into something of a desired concentration. First, let's talk about what a stock solution is. A stock solution is merely a solution that we make by ourselves, and we know the concentration of solute to a very precise and very accurate manner. And to do this, we need to use very precise glassware. And the most precise glassware we can use in chemistry are volumetric flasks and pipettes. These are new tools that you may not have worked with before, but they are more accurate than beakers and flasks. Graduated cylinder is another tool that we can use in science, and graduated cylinders fall somewhere in between volumetric flasks and pipettes and beakers and flasks. They are accurate to a somewhat certainty, but not as accurate as volumetric flasks and pipettes. The volume of each volumetric flask is indicated on the side of the container. So in this case, we have a 500 milliliter container. This container will only measure 500 milliliters when the volume of solvent is raised to that particular line. If you were to make a solution of a different volume, then we use a volumetric flask of a different size. Here are the steps to make a stock solution. First, you need to weigh out how much the solute that you want to use in your solution by weighing in a small beaker. Then you dissolve it in a small amount of water. I would say about 1/5 or about 20% of the final volume. So if you wanted to make a solution of 100 milliliters, you would dissolve all your solute at first using about 20 milliliters of water. Then you transfer that 20 milliliters of your solution into a volumetric flask. In this case, if you're making a 100 milliliter solution, you would transfer it to a 100 milliliter volumetric flask. Then you would rinse a small beaker that you dissolved everything in with a small amount of water again, so another 20 mils in our case. Pour the volume of water into the volumetric flask, and then you have to repeat the rinse procedure 1 or 2 times. So by now you would have about 60 or 80 milliliters of water in your volumetric flask. Then you would slowly add more pure distilled water into your volumetric flask. It's very important that you do not overshoot the calibration mark. Once you've reached the 100 milliliters of water in your volumetric flask, you should cap the volumetric flask and then mix by inverting or putting it upside down about 8 times. Once that's done, you have to transfer it to a dry beaker, and we need to have a dry beaker because we do not want to introduce any more water into the solution. After that, you can pipette and work with your stock solution as you need. If you want to make a solution that is less dilute than the original concentration, than your stock solution, so then you need to do something called a dilution. So for example, if your initial concentration was 1 mole per liter and you want to make it to, let's say, 0.25 moles per liter, then you need to do this procedure. So after your stock solution is in a dry beaker, you need to pipette the appropriate amount of stock solution into a new volumetric flask that is clean. It's okay that it's wet, but it's essential that it is clean. Then again, just like before, you have to add water into your new volumetric flask up to the calibration mark. And once again, don't overshoot. And the bottom of the meniscus should be at the top of the calibration line. After that, you have to cap your volumetric flask and then invert it to mix. When we refer to a meniscus, that is the curved appearance of water against a glass surface. So here on the side of the volumetric flask, we see the water has climbed up to the sidewall. However, when we read the volumetric flask, the line on the volumetric flask, we need to ensure that the line of the water is right at the bottom of the meniscus is at the line. So that is an accurate reading. Whereas in this case, there's not enough water in your volumetric flask. And then lastly, in this case, there's too much water in your volumetric flask. Neither of these are good, and you must have the meniscus at the line here. So how do we determine how much solute we need to weigh out to make our stock solution? Well, you need to do some chemistry math. So in this example, we are asked, how much sodium nitrate do you need to weigh out in order to make 500 milliliters of a 0.75 molar solution? And remember, molar means moles per liter. So let's do our math. We know our volume is 500 milliliters, or 0.500 liters, multiplied by 0.75 moles per liter, and that gives us 0.375 moles. Now that we have moles, we need to find how many grams that is equivalent to. If you remember, the formula for sodium nitrate is NaNO3, and the molar weight for that is 85 grams per mole. So now we take 0.375 moles multiplied by 85 grams per mole equals 70.6 grams, because here the moles cancels out. And then finally we round for 67 digits, that's 71 grams. That means we need to weigh out 71 grams of sodium nitrate in order to make 500 milliliters of a 0.75 moles per liter solution. Let's do another example, but this time we want to find how much calcium nitrate we need to use to make 300 milliliter of a solution with a nitrate concentration of 0.5 moles per liter. So, and we're using calcium nitrate here. So because we want to find the concentration of nitrate, that suggests to us we need to do a dissociation equation. So let's write the dissociation for calcium nitrate. CaCONO3 2, when placed in water, dissociates into 1 calcium ion and 2 nitrate ions. And we want to work with the nitrate ions. So we have a concentration of nitrate that is 0.5 moles per liter of nitrate. And now we need to find the concentration of calcium nitrate, because that is what is available to us in the form of a solid. And the molar ratio here is 2:1. We have 2 moles of NO3 for every 1 mole of calcium nitrate. So we have to do our math here, and the math we have to do is to divide 0.5 moles per liter of NO3 by 2, so that the NO3 cancels, leaving us with 0.250 moles per liter of calcium nitrate. Now we can continue to find how much mass of calcium nitrate. So we know our concentration of calcium nitrate is 0.250 moles per liter, and we want to make 300 mils, or 0.3 liters. So that's going to be 0.075 moles of calcium nitrate. And remember, our units cancel out here. Our liters and liters are canceled out. Then we have to multiply by the molar mass of calcium nitrate, which I determined earlier was 164.10 grams per mole. So we take our 0.075 moles of calcium nitrate, multiplied by 164.10 grams per mole, and the math here is 12.3 grams. So that means we need to weigh out 12.3 grams of calcium nitrate in order to make 300 milliliters of a solution of with a nitrate concentration of 0.5 moles per liter. I encourage you to try some questions on your own, on your practice booklets, and send us any questions if you have any concerns.